Okay, Michael from CTW Automation here, and we wanted to continue on making a useful and consistent test. So we talked about how to get the damper in the dyno, what to do, preload, all those things. We've talked about the warm-up, whether we're doing timed or temperature. The next thing we really want to do is understand about the rod force, multi-point rod force, and maybe even seal drag, depending on what it is you're trying to get out of each and every run. So, just to understand rod force. So, you have a damper, and it's got a separated piston, a nitrogen chamber. As this shaft is compressed into the damper, whether it's through preload or whether it's through the dyno actually running, this shaft goes into the chamber, and that amount of fluid, the volume of the shaft that goes in, has to be displaced. It's got to go somewhere. So in a damper like this, where you have a divider piston and a gas chamber, it goes into this chamber and compresses the nitrogen. So that is the measurement we're taking. Now, what does that mean? Well, if you compress the damper, you let it go, it pushes the shaft out. We displaced the fluid, we've increased the pressure, it's pushed the shaft back out. We're trying to measure that rod force, and we want to measure it, and we write it down, and then we try to take it out of the data. We do that in various ways, and we'll talk about that in a minute, but that's the rod force. We want to do that. Now, what is it really? Well, statically, it's a spring. It's a component, and as the damper gets hotter and the nitrogen chamber builds up temperature, you get more rod force, more spring rate. You know, PV equals nRT, and temperature being the big one, and it's related to pressure. Now, if you think about it, famous cases are during the race, the dampers get hot, right? They get hot, they increase in temperature. The gas chamber gets a higher pressure. The rod force builds up. What happens then? Lifts the car a little bit. So that's why people fight so hard to get as low as a gas chamber pressure as they can without cavitating, because that's another spring that changes with heat. That's why we use nitrogen, because it's more constant. That's why we use base valves and so many various ways to try to trick it, including starting your shocks in the race. Maybe they're even close to cavitating, because after 5 laps, the temperature comes up and there's enough pressure internally to keep it from cavitating. There's all kind of things that people have tried, and I can tell you I'm certainly one of those along the way. So this rod force, we want to measure it. So the rod force happens statically, and I have this graph up here that I've done, and I've posted this numerous times. So the rod force in the dyno runs, and you'll see the yoke go up to mid-stroke, and it stops, pauses for 2 seconds or whatever the user has told it to do, and takes a measure of the load cell. Then it goes up to the top and comes back down to the center again, pauses to let it settle, and takes another reading of the force. We add those two forces together, divide by 2, and we say that's the rod force. That's the static spring rate at mid-stroke, and we remove it from the data. Why do we remove it from the data? Because when you put the dampers on the car and you set the ride height, you're accounting for the rod force. You're accounting for that static spring, not the dynamic component, but the static spring as a function, and we take it out of the data. If we don't do that, say you have a 100 psi damper and you graph it, if you were to put 300 psi in there, the rod force would increase. It would actually raise your car. You might take a turn or two out, but on the dyno, you'll watch it go up the graph. Well, if we take the rod force out, we take that number out so that the damping, the dynamic component, will match regardless of the pressure in the damper. Now, there's some other fun things you can do with more advanced machines to look into that, but the simple part is that's how the rod force works. Now, we have the second component of a multi-point rod force. Well, why would we do a multi-point rod force? Well, there's a lot of dampers that have a lot of stroke, motorcycle forks, and off-road trucks, off-road 4x4s, things like that. So they have a lot of stroke. So from bottom dead center to top dead center of their stroke, that nitrogen chamber adds a large difference to the rod force. So instead of just doing it mid-stroke, what we'll do is we'll set up a multi-point. So we'll do it in stages where we go up and do the same thing coming back down, and we're averaging that and creating a line, a curve fit, so that we remove the rod force based on the position. And if you've ever seen your force first displacement graphs rotated, there is a spring component in there that you may want to think about doing a multi-point rod force on. So that's very important, and keep in mind. Short little 2-inch stroke dampers or testing machines, you don't typically see that. When we get to the bigger machines that have 100 millimeters or 160 millimeters, you may get into that even more. So you have to decide whether you're doing a rod force or a multi-point rod force. Seal drag is the last component. I very rarely see this in racing. People looking at the racing, they want to go, they just use the rod force or the multi-point. Manufacturers are very big on a seal drag. So the rod force and the multi-point, they'll stop, measure the load. The seal drag actually moves at a very slow speed, and it takes all the data while moving at a slow speed in a window. So it is an attempt to measure the friction, dynamic friction, seal drags, things like that, while moving slow enough that you omit the valving. Yeah, sometimes that works, sometimes it doesn't. It's a bit of a trick. If you can open your adjusters and allow a lot of bleed, your seal drag numbers will be more representative of the actual internal friction. For a no bleed shock, you're not going to be able to do a seal drag because the pressure buildup is just going to be too high and it's never going to settle. But things to keep in mind as to why you would do a static rod force, a multi-point rod force, or a seal drag. Now you can do a combination, and a lot of manufacturers will do the combination. They'll do a seal drag and a rod force, so they have both data points, both information. But this gives you a lot of power in our software to get anything you want or everything all at one time. So that's the rod force. So we're talked about mounting the shock, getting it in there, preloaded, doing a warm up. Now we've talked about the rod force, how to use it, how to work with it, and we're actually going to do a deeper dive on this because when it pertains to a no bleed damper, it's critical how you do it. Look for that video in the future. And next we're going to go into actually building a useful test, getting all these things together and getting you the most use out of your machine. There you go. Thank you for watching. If you have any questions or comments, contact us using the information in the video description.